Topic 1, Planet Earth, Part 1, the Earth's structure. And the first thing to note about the Earth's structure is the size of it. So the Earth's diameter is about 13,000 kilometers. So diameter, remember, is from one side to the other side, and it's about 13,000 kilometers. So 13,000 kilometers all the way across. And the other thing to note is not a perfect sphere. It's actually squashed a little bit. If you imagine you sat on squash from the top, it's squashed down a little bit. And it's about 42 kilometers wider at the equator than it is from pole to pole. And because of that, it's not what we call a sphere, but it's what we call an oblate spheroid. So, oblate spheroid, which is a fancy way of saying squashed sphere. Oblate spheroid. Now, we need to know about the structure of the Earth, so what it's made up of. So I've got my cutaway diagram here, and the first thing I'm going to mark on or draw on is the crust. Now the crust is really quite thin compared to the full diameter of the Earth, so it's only going to be a little bit of pen work here, just to make that look a little bit thicker there. And that's our first part. That is the crust. So I'll label that up as the crust. And it's the part that we walk about on. Okay, it's about 8 to 70 kilometers thick. So very thin compared to 13,000 kilometers in diameter all the way across. And the other thing to note, it's you're probably aware from your geography studies, it's made up of tectonic plates. And it's generally made of iron, oxygen, and silicates or silica materials. And the temperature is about 20 degrees Celsius. And that's main features of the crust. Now the next part is the biggest part, and I'm going to draw that from about here. Here we go. So it's this large area in here, and it's what we call the mantle. The mantle. And the mantle is about 80% of the Earth's volume. Of Earth's total volume. So it's the main part of Earth is mantle. Most of Earth is mantle. And it's rocks that are a high temperature. They would normally be sort of liquid at that kind of temperature, but actually, because they're held under pressure, they behave much more like a solid. So I'm going to call it rocks, which are solid due to pressure. If you imagine your particle models, when you draw your liquid particles moving around a little bit, they're all held so much pressure that they can hardly move, and they behave much more like a solid. So it's rocks which behave like solid due to the pressure. It's about 2,900 kilometers thick. And the temperature is about 1,400 degrees to about 2,000 degrees Celsius. So that's our mantle, this area here. In here we've got our core, and the core gets broken up into two parts. We've got the outer core, which is now here. Let's label that. This area here is the outer core, and then we've got the final bit here, which is the inner core. But first of all, the outer core. So the outer core is liquid iron and nickel. and they're what causes the Earth's magnetic field. So this flowing of this liquid iron and nickel causes the Earth's magnetic field, and in later topics you understand the huge benefits of the Earth's magnetic field to us. It's about 2,900 kilometers thick, like the mantle, so similar thickness to the mantle, but because it's a much smaller sphere, much further inside the sphere, it represents far less of the volume than the mantle does. So it's about that much thick, and its temperature is about 3,500 degrees to about 4,000 degrees. And then finally, we've got the inner core here, so right in the centre, inner core. And that can be described as a sphere of liquid iron. So, liquid iron. It's about 1,200 kilometers thick. And it's the hottest part. It's about 5,000 degrees Celsius. It's about 6,000 degrees Celsius. So some brief notes there, but the key notes there that you need to know about the Earth's structure.